Hello, and welcome to my presentation on software testing. As we move into an age of continuously growing technology, software has become an important backbone of our daily lives. Without it, large computer systems would cease to function properly, leaving us in a vulnerable state. It is through software testing that companies aim to minimize the defects that are found in their programs. While it is impossible to eliminate all of these errors, testing is an incredible tool for identifying and preventing many issues that may cause harm in the real-world system. So as I just mentioned, software testing is extremely useful for figuring out where problems may occur in a program. These problems go by many names and are commonly referred to as bugs or defects. Oftentimes, these bugs can be attributed to human errors, where a developer either misunderstands the specifications or there is a mistake made with the functionality of some of the code. Other issues are out of human control, such as electrical component failures due to overheating or dust. There are many reasons why a system may not work properly, but the goal of testing is to eliminate as many of them as possible. There are many examples of times when software has created significant issues due to a lack of detailed testing. Throughout history, you can see issues with planes, where the autopilot malfunctions, or flight coordinates are thrown off. In the 80s, defense systems in both the US and Russia had falsely reported missile attacks, nearly starting a nuclear war. Notably, in 1998, the United States launched a Mars climate orbiter, which unfortunately crashed nearly immediately upon arriving at Mars. The issue is attributed to a conversion error. One of the engineering teams was using metric units, while another was working with standard units. Due to this inconsistency in the code, the thrusters malfunctioned, and the $327 million project had crashed and burned after a year of space travel. Dr. Edward Wheeler, NASA's Associate Administrator for Space Science, said that the problem was a failure of NASA's systems engineering and the checks and balances in their processes to detect the error. Had they properly run all of the tests and covered their bases, it is much more likely that the climate orbiter would have succeeded in its mission. So when is it the best time to test software? Clearly, these bugs have a severe impact on the success of projects and missions. A study in 2002 showed that over $59.7 billion are lost due to software bugs in the U.S. alone each year, and over $22.2 billion of that could be saved by improved testing. It is shown that the later in the software lifecycle that a bug is detected, the more costly it becomes. This is because it generally takes more time, money, and effort to fix all of the code that has been built around it. If code has already been shipped to customers, it creates an even larger mess of needing to deal with the customer's problems and fix the entire product. As seen in the graphs, bugs found in the post-release phase may cost up to 100 times more than the earliest stages of development. More important than the financial costs are the harmful consequences on human lives. When developing code that deals with people's well-being, there is a much larger need to be well covered by tests. From 1985 to 1987, there were several cases of overdoses of radiation treatment to patients using the Therac-25 radiation therapy device, leading to 6 deaths and many more injuries. The issue here was that a 1-byte counter would sometimes overflow, and if the operator sent a command at this time, the machine would skip part of its setup procedures. When this happened, the software interlocks would fail, and the machine would give patients expecting a low dose of radiation a significantly higher dosage. These were up to 100 times more radiation than the patient was supposed to receive, and as a result, killed 6 people. Especially with human lives on the line, testing becomes extremely more important. When testing software, there are many different levels of code that need to be properly checked. The lowest level is called a unit test. This type of test checks individual components of the software, such as functions, procedures, and small programs. These units generally take in a few inputs and produce a few outputs. The next level above unit tests are integration tests, which look for defects in the interactions between components. The goal of these tests are to make sure that as the pieces of the system are put together, their behaviors do not affect each other in adverse ways. A good example would be to think of a pen. The cap, ink, body, and cap can all be unit tested individually, but an integrations test will make sure that as the pieces are starting to be put together, everything still functions properly. This would be something like making sure the body of the pen fits into the cap, and so on. Once these integration tests are complete, a systems test is conducted. This is simply testing the complete product to ensure that everything together works as expected. Finally, an acceptance test is run. These tests are the last step and make sure that the finished product fits the user's needs and requirements. In the pen analogy, this would mean making sure that the pen itself is ready to be made available for the users. All of these tests work with various levels of abstraction. Testers will employ black box, white box, and gray box techniques to ensure that every test covers exactly what it needs to. These create an efficiency that allow developers to be sure that the code they have written will get the job done well. In terms of testing strategies, there are many different approaches that engineering teams will take when devising their test plans. Waterfall testing is one of the simplest testing approaches and is mostly useful on small projects with unchanging requirements. This strategy is a sequentially ordered plan where one phase is only started after the previous phase has been fully completed and reviewed. While it can be a simple approach to implement, it makes it very difficult to go back and make changes to things that were missed or incorrectly implemented. Another strategy is extreme programming. This approach to software development focuses on pair programming and extensive code review. Every piece of code is unit tested and the syntax is developed for simplicity and clarity. This approach also relies heavily on test-driven development. TDD, as it is commonly called, follows the order of building a test before writing any function. These tests are first run to ensure that they all properly fail, and after this is confirmed, then the developer can write the code. Once complete, these tests are run again to make sure that they all pass. If something doesn't pass, then the code is fixed and refactored. After every change to the code, the tests are rerun to validate that everything is still working properly. This approach is very valuable because, if done correctly, it will reduce the chance of building incomplete tests. Generally, people will have a tendency to build tests around the code that they have already written, but TDD focuses on writing the tests first to cover all cases, and then writing code that will satisfy these requirements. All in all, it is safe to say that testing is very important for many reasons. When testing is done improperly or isn't complete, then bugs that exist in the code will be exposed. Sometimes the consequences are negligible, but other times they can be severe. Most companies these days rely heavily on their testing to provide their customers with the product that they want. With many different testing strategies available for use, the important thing is to make sure that some sort of testing process is used. For different projects, certain approaches may be better or worse, but as long as some method is used, a company will be better protected from the issues that could potentially ensue. There are numerous other methods and ways that people test software, but the few mentioned in this presentation are some of the more popular strategies that help many developers succeed at their jobs. I hope this has been a good taste on the importance of software testing, and I thank you for your time.